What if I told you that two of the most advanced telescopes ever built by human hands accidentally photographed the exact same ancient traveler from another part of the galaxy, and neither team even realized it at first? And what if I told you this object is older than the Sun, older than the Earth, older than almost every star you have ever looked up at on a clear night? Before I go one word further, do me one small favor. Hit that like button, smash subscribe, and share this video with one person who still thinks space is boring. Because by the end of this, I promise, you will not look at the night sky the same way ever again. The real beginning of the story is not 3 minutes ago. It is not even 3 weeks ago. It goes back to a quiet night in Chile on June 21st, 2025, when a giant new telescope, still in its testing phase, was just calibrating its systems. It was pointed at a random patch of sky. It was not searching for anything special. It was doing what engineers call housekeeping. And in the background of those simple test images, sitting there like a stranger who had wandered into someone else's family photo, was an object that no one on Earth even knew existed yet. 10 full days would pass before humans would officially discover it. 10 days where an ancient interstellar traveler was drifting through our solar system, being quietly photographed by one of the most powerful cameras ever built, while every scientist involved had no idea what was hiding in their own data. Now let me take you to July 1st, 2025. That is the day humans officially met this object for the first time. A survey system called ATLAS, short for Asteroid Terrestrial Impact Last Alert System, based in Rio Hurtado, Chile, picked up something strange moving through space. At first, it was just a technical code, C2225N1, nothing dramatic, just another point of light. But within a few days, astronomers started noticing something that made their hearts race. The object was moving too fast. Its path was too sharp. Its angle was too extreme. It did not belong here. It was not born in our solar system. It had come from somewhere far, far away from the deep, dark space between the stars. And that made it only the third confirmed interstellar visitor in human history. It was given a new name, a name that sounded almost gentle for something so mysterious. 3I Atlas. The moment that name was announced, telescopes all over the planet started swinging in its direction like sunflowers turning toward light. Everyone wanted to see it. Everyone wanted a piece of its story. And that is when a group of scientists at the brand new Vera Rubin Observatory did something clever. They asked a simple question. What if we already saw it and just did not know? So they opened up their archived test images from earlier in the year. They started scrolling through old calibration frames. And there it was, sitting right there in the background of images from June 21st. 10 days before the world even knew this thing existed, the telescope had captured it by pure accident. Think about how wild that is for a moment. A telescope, still learning how to see, still stretching its digital muscles, still practicing before its real mission started, just happened to be pointed at the one tiny patch of the entire sky, where an ancient interstellar object was quietly passing through. If it had turned even a few degrees to the left or right, that data would not exist. If it had tested its systems on any other night, it would have missed it. It was chance. It was luck. It was one of the most beautiful accidents in the history of modern astronomy, and it did not stop there. Rubin kept photographing 3I Atlas again and again, all the way through July 20th, 2025, nearly 100 exposures in total. Researchers eventually used 49 of them in a full scientific study. Those images ended up being among the earliest and clearest pictures of this object anywhere on Earth. And every single one of them was captured before humanity even knew there was something to look at. Let me tell you what those images actually showed, because this is where the story starts to get personal. The object had a growing coma, which is basically a cloud of gas and dust wrapped around its solid core, like a soft, glowing scarf. That coma grew more than 50% larger during the observation window, because as the object got closer to the sun, it started warming up and releasing more material. That part is normal. Every comet does that. But there was one detail that made scientists lean in a little closer. The dust tail was pointing toward the sun instead of away from it. And that is unusual. Almost every comet you have ever seen has a tail that stretches away from the sun because sunlight physically pushes tiny dust particles backward. A tail pointing toward the sun is rare enough to make some people whisper the word alien. But before your imagination runs off, let me give you the calm scientific answer. It is called anisotropic dust emission. That is just a fancy way of saying the dust was not being released evenly from every side of the object. It was coming off in patches, at angles, in bursts, and depending on how you view it from Earth, that can create a tail that looks like it is pointing the wrong way. It is unusual, it is beautiful, but it is not proof of anything mysterious. It is physics doing what physics does. Now, here's the part that really deserves your attention. This telescope, the Vera Rubin Observatory, was not even officially in service yet. It was sitting on a mountain called Cerro Pachon in Chile, chosen for its dry air, dark skies, and cold, clear nights. Its main mirror is 8.4 meters wide. That is about as long as a tennis court. Attached to it is the LST camera, the largest digital camera ever built in the history of the human species. It captures images at 3,200 megapixels. Your phone camera captures maybe 12 to 50 megapixels. Just imagine the level of detail here. And this monster of a machine was in its warm-up phase, its dress rehearsal, its practice sessions, before its real 10-year mission began. That is why nobody noticed 3I Atlas at first. They were not looking for a comet. They were checking their equipment. And yet the equipment saw one anyway. If you are enjoying the story so far, and if that little goosebump feeling is starting to travel up your spine, I want to ask you something quickly. Pause for 1 second and tap that subscribe button. Not because I am asking, but because this channel breaks down the biggest space discoveries in plain, honest, easy-to-follow English. Without the fake drama, without the clickbait nonsense. Turn the notifications on, drop a like, and let the algorithm know this story deserves attention. And come right back, because what comes next is where the story truly opens up. The precision of these Rubin images was incredible. The telescope observes in 6 different color filters labeled U, G, R, I, Z, and Y. That means it captures different wavelengths of light, from ultraviolet to near-infrared. And for 3I Atlas, it measured its position to about 70 milliarc seconds of accuracy. Let me put that in words a human can actually feel. Imagine holding a coin at arm's length and being able to detect that it moved by a hair's width. That is roughly the level of precision we are talking about, only much finer. That level of accuracy allowed a research team led by astronomer Colin Orion Chandler, along with more than 300 collaborators, to publish a full scientific paper. Based entirely on this accidental early data, they mapped its position, its brightness, its shape, and its activity, all from images that were taken before the object was even officially announced. It is like finding a diary you did not know you were writing. And here is something worth thinking about. The scientists working with Rubin did not stumble upon this by luck alone. They knew that once 3I Atlas was announced, there was a real chance their earlier test data might contain it. So they went hunting. They wrote software. They ran computations. They cross-checked positions against the object's known path. They peeled back layers of archived data like archaeologists brushing dust off an ancient artifact. And when they finally saw that faint moving dot appear in a June image, they must have felt something few of us will ever feel. The quiet thrill of realizing that the universe had been leaving footprints in your own house long before you ever thought to look. That moment of discovery is why people fall in love with astronomy. It is why so many young students choose this field. Not for the fame, not for the money, but for the chance to be the first human eyes to notice something buried in plain sight. Now, let us jump forward to August 6th, 2025. This is where the James Webb Space Telescope enters the story. Webb is different from Rubin. Rubin is like a giant wide-angle camera made to scan huge patches of sky. Webb is more like a laser-focused magnifying glass made to stare deeply at one target at a time. On that day, Webb pointed its near-infrared spectrograph, called NIRSpec, directly at 3I Atlas. Instead of just taking a picture, Webb did something more powerful. It broke apart the light coming off the comet and read it like a barcode. Every gas, every molecule, every ancient element, all encoded in tiny signatures inside the light. And Webb found something that made scientists sit up straight in their chairs. Inside the coma of this ancient traveler were gases. Carbon dioxide, water, water ice, carbon monoxide, and a strange smelly molecule called carbonyl sulfide. Now, on their own, those are all normal comet ingredients. Nothing shocking there. But the ratio of carbon dioxide to water was the highest ever recorded in any comet. Any comet, not just interstellar ones. Any comet ever observed by humans. That ratio matters because it is basically a fingerprint of the environment where this object was born. Cold places create certain ratios. Warm places create others. Regions rich in certain gases create others. And 3I Atlas had a mix that told us it did not grow up near our neighborhood. Then, in December 2025, Webb took a second look, and this second look changed everything. On October 29th, 2025, the comet made its closest approach to the Sun, a moment scientists call perihelion. As it swung around, its ancient ice heated up and turned into gas at a rapid pace. The coma exploded with activity. Then, on December 19th, it passed closest to Earth at a safe distance of about 168 million miles, posing zero danger. 3 days later, on December 22nd, Webb captured its second detailed spectrum. And this time, it measured something remarkable. The ratios of carbon and deuterium locked inside the comet's ice. Deuterium is sometimes called heavy hydrogen, and these particular ratios did not match anything ever found in comets born inside our solar system. Working backward from that chemical fingerprint, scientists estimated something almost impossible to believe. This comet formed between 10 and 12 billion years ago in a cold, distant part of the young Milky Way Galaxy. Let that number sit for a moment. Our own solar system is only 4.6 billion years old. That means the ice and dust inside 3I Atlas were already frozen for billions of years before the sun even lit up for the first time. Some researchers pointed out that this makes it nearly as old as the universe itself, estimated at 13.8 billion years. This is not just a comet. This is a piece of frozen history from a time when the galaxy itself was still young. This research was published in the journal Nature on June 22nd, 2026, after passing through peer review, meaning independent scientists checked the numbers, tested the logic, and confirmed the conclusions before it was allowed into the world. Now, I know the question you're thinking. Everyone online is thinking it. Is this an alien object? Let me answer you honestly, calmly, and with respect. No, it is not. And I want you to know exactly why. First, the object behaves exactly like a comet should behave. It develops a coma. It releases gas and dust as it heats up. It obeys the same rules as thousands of comets we have studied for over a century. Second, its chemistry is normal comet chemistry. Different ratios, yes, but the same core ingredients. There is no exotic metal. There is no engineered signal. There is no hidden material. Third, its path follows the pure math of gravity. No sudden turns. No mysterious acceleration. No signs of steering. Every single measurement point to one honest conclusion. This is a completely natural comet. Just an ancient one. Just a foreign one. Just a very, very special one. But I want you to understand something important. The truth here is more thrilling than any alien story could ever be. Because think about what this really is. It is a physical, tangible piece of another era of our galaxy. A chunk of frozen material from a time before Earth existed. From a place none of our spacecraft could ever reach. Drifting quietly through the darkness for billions of years. And then, by some cosmic coincidence, passing through our neighborhood exactly when we had the instruments to study it. Scientists have compared it to finding a message in a bottle that has been floating for billions of years. Except the ocean is the entire galaxy, and the bottle is made of primordial ice. That is not science fiction. That is real. Let me pause here for a heartbeat, because if this story is making you feel something, leave a comment below. Just one word, just one thought. Tell me what part of this shook you the most. Was it the accidental discovery? Was it the sunward-pointing tail? Was it the age older than the sun itself? Your comment helps this video reach more curious minds. Let me explain that age estimate a little more because it is honestly the most jaw-dropping part of this whole discovery. Deuterium is heavier than normal hydrogen because it has an extra neutron inside its nucleus. The ratio of regular hydrogen to deuterium inside frozen water changes very slowly and very predictably based on temperature and radiation. Think of it like a chemical clock ticking softly across billions of years. When ice forms in colder places, more deuterium ends up locked inside. When it forms in warmer regions, less does. By measuring that ratio, scientists were able to almost read the label on when it was made. That is called galactic chemical evolution. And the reason it works is beautiful. Our galaxy has been changing its chemical mix for billions of years. Every time a star lives and dies, it seeds space with heavier elements. So the older an object is, the fewer heavy elements it carries. 3I Atlas carries an incredibly ancient signature, one from a time when the Milky Way itself was still figuring out what it wanted to become. Now, let me put its physical numbers on the table too, because they are just as impressive. This is only the third interstellar object ever confirmed inside our solar system. The first one was Oumuamua. Discovered in October 2017, it was strange, weirdly stretched, cigar-shaped, and showed a small, unexplained acceleration. That caused a lot of alien theories online, but most astronomers agreed it was probably caused by natural venting. The second was 2I Borisov, spotted in 2019 by an amateur astronomer in Crimea. Borisov behaved much more like a typical comet. Complete with a tail and coma, it gave scientists a first real chance to study interstellar chemistry up close. 3I Atlas is the third, and honestly, it might be the most extreme of the three. Its orbit is extremely hyperbolic, which is a fancy way of saying it does not curve gently but slices through space like a knife. Scientists measure orbital shape using something called eccentricity. A value of 1 is the line between a loop and a departure. 3I Atlas has an eccentricity of about 6.14. That is a huge number. It confirms this object was never bound to our sun, not for a second. It just came, waved hello, and kept going. It was traveling at about 137,000 miles per hour. Based on its speed and trajectory, scientists calculated something called a kinematic age. That is basically an estimate of how long the object has been drifting through interstellar space alone. Their answer was somewhere between 3 and 11 billion years, which lines up beautifully with the chemical age estimate from Webb. Two totally different ways of measuring, and they still agreed. That is how you know the science is solid. Researchers also mentioned that statistically this comet has probably not passed near another star as closely as it just passed our sun, meaning our little corner of the galaxy may have been its closest cosmic encounter in billions of years. Its solid core, or nucleus, is estimated to be somewhere between 440 meters and 5.6 kilometers wide. Based on Hubble Space Telescope observations, that is a fairly wide range, because measuring such a small, dust-covered object is tough. And it was not just Webb, Rubin, and Hubble watching. This became one of the most observed objects in recent history. NASA's SphereX mission looked at it in infrared and detected dust, water, organic molecules, and carbon dioxide. NASA's TESS mission was redirected specifically to observe the comet's activity and rotation. Even a European spacecraft named JWST, currently traveling toward Jupiter's moons, managed to photograph it in November 2025. Multiple telescopes, multiple spacecraft, multiple methods, one ancient traveler, all working together like an orchestra. Before we go deeper into what this all means, I want to take one more short moment with you. If you have made it this far, you are clearly someone who thinks about the bigger questions. Ring that bell for notifications. Share this video with one friend who loves space or thinks nothing exciting ever happens in science. Because stories like this are exactly what remind people that the real universe is stranger, older, and more beautiful than they imagined. Now, back to the story. So why does it matter that Rubin and Webb both ended up staring at the exact same object? Because together, they are two halves of one perfect eye. Rubin is speed and coverage. It scans huge sections of sky. It is the reason we can catch fast-moving, quick-passing visitors before they slip away. Webb is depth and detail. It stares hard at one target and reads its chemistry down to the molecule. Rubin found the object first by accident. Webb figured out what the object actually was, where it came from, and how old it might be. Neither telescope alone could have told the full story. Rubin gave us the footprint. Webb gave us the DNA. And together, they gave humanity something we have never had before. A first-hand chemical portrait of a time capsule. This story also hints at something even bigger. The Vera Rubin Observatory officially began its full 10-year survey in 2026. Its entire mission is to scan the sky every few nights, catching whatever new or unexpected thing might drift into view. Asteroids, comets, rare interstellar visitors. The fact that Rubin caught 3-eye Atlas during testing is a jaw-dropping preview. Scientists expect more interstellar objects to be discovered in the coming years, and Rubin will likely spot many of them. Meanwhile, Webb keeps doing what only Webb can do from 1.5 million kilometers away from Earth. It orbits in the cold silence of deep space, far from the light and heat interference of our planet. That distance is what allows its instruments to detect the faintest whispers of infrared signals. Together, Rubin and Webb form something we have never had before. A wide-angle scanner and a deep space detective. One catches the whisper, the other decodes the message. And 3-eye Atlas became the first great case study of this partnership. There is something else worth mentioning because it deserves its own moment. The higher than normal carbon dioxide ratio. Comets that form in colder, more distant regions tend to lock in more carbon dioxide because of the freezing point. So, a comet packed with unusually high levels of frozen carbon dioxide tells you it was formed far away from any warm star. That single piece of data suggests 3-eyes Atlas grew up in an extremely cold, distant part of a stellar nursery. It is a small clue, but it opens up a huge picture. We have physical evidence of the outskirts of very old star systems. That is astonishing. That is a level of scientific reach that would have seemed impossible even 20 years ago. Right now, 3-eye Atlas has already passed its closest point to the Sun and to Earth and is heading back into interstellar space. Scientists gathered every last piece of usable data they could before it became too faint to see. Ground telescopes, space telescopes, and spacecraft on other missions all cooperated in what became a symphony of observation. It is likely that no human will ever see this object again. It came, it revealed itself, and it left, all in months. But it left behind something priceless. It left a chemical portrait of another chapter of the universe. It left evidence that ancient ice, older than the sun, actually exists and actually drifts through the galaxy. It left proof that the Vera Rubin Observatory is going to redefine how humans discover objects in the sky. It left the James Webb Space Telescope with a new record for the most carbon dioxide-rich comet ever measured. It left a small, humble reminder that the biggest discoveries often come from having the right eyes open at the right moment. And maybe that is the most beautiful part of all. The universe does not save its greatest gifts for the loudest researchers. Sometimes it whispers them into the background of a random test image on a cold Chilean night. Sometimes it tucks them into old data waiting to be rediscovered. Sometimes it makes ancient wanderers pass through briefly. So no, 3i Atlas is not a terrifying alien object. It is not a threat. It is not a secret warning. But what it truly is might be even more impressive. It is a real, physical, chemical fingerprint from a time before our world existed, confirmed by 2 of the most powerful telescopes ever built and studied by an international lineup of instruments, discovered twice, once by accident and once on purpose, before quietly leaving our lives forever. If this story gave you even one tiny chill down your spine, remember that you are alive during a golden age of discovery. Never before have humans been able to reach so far, see so deep, and understand so much about the universe. Every year from now on, more stories like this one will emerge, thanks to telescopes like Rubin and Webb. You are witnessing history in real time. This channel exists to bring those stories to you in plain, easy-to-follow language. If you enjoyed this story, subscribe now, hit the bell, share this with someone you love, and drop a comment. I read every comment, and each one helps this channel grow. Thank you for staying curious. I will see you in the next one.